Estimating the fair price for electrical equipment involving a 480-volt, 400-amp system requires considering several key components and labor aspects. The primary materials affecting the overall cost include 3 480-volt, 400-amp circuit breakers, the 400-amp gear itself, 30 feet of 4-inch electrical metallic tubing, 12 feet of additional piping, and the motor load. Each of these material elements contributes significantly to the overall expense. The cost of labor is a substantial part of the total project expenditure. This includes the cost of installing the electrical equipment, running and terminating the conduit, and connecting the motor load. The complexity and time required for each of these tasks will influence the labor charges. Local market conditions play a crucial role in determining the final price. Variations in material costs and labor rates across different regions can impact the overall project expenses. The availability of materials and labor also affects pricing. Scarcity or high demand for specific materials or skilled labor can drive up costs. The contractor's profit margin is another important factor to consider. Contractors typically include a profit margin in their bids, which can vary depending on their overhead and desired return. Based on current pricing, a reasonable estimate for the equipment and installation costs would be in the range of $15,000 to $25,000. This range accounts for fluctuations in material and labor costs as well as regional differences. A detailed breakdown of costs can provide better clarity. The estimated cost for materials ranges from $8,000 to $12,000. This includes the circuit breakers, gear, conduit, and other necessary components. Labor costs are estimated to be between $5,000 and $10,000. This covers the installation of equipment, conduit work, and motor load connection. Other costs, such as permits, inspections, and miscellaneous expenses, can amount to an additional $2,000 to $3,000. It is important to note that this is merely an estimate, and the actual price may vary depending on the specific circumstances of the project. Factors such as the complexity of the installation, the condition of the existing electrical system, and any unforeseen challenges can affect the final cost. To ensure you get the best possible price, it is always advisable to obtain quotes from multiple contractors. Comparing quotes from different contractors allows you to assess the range of prices and select the most competitive offer. When obtaining quotes, provide contractors with detailed specifications of the project, including the equipment required, the scope of work, and any specific requirements or constraints. This will help contractors provide accurate and comprehensive bids. It is also advisable to check the credentials and experience of contractors before hiring them. Verify that they are licensed and insured and have a proven track record of completing similar projects successfully. Request references from previous clients and review their online ratings and reviews to gauge their reputation and quality of work. Consider the following detailed aspects to refine the cost estimation. Firstly, circuit breakers contribute significantly to the overall material cost. The type and brand of circuit breakers can affect their price. For example, molded case circuit breakers are commonly used in these applications. Secondly, the 400-amp gear includes the panel board or switchboard that houses the circuit breakers. The size and configuration of the gear will influence its cost. Consider whether the gear needs to be NEMA 1 or NEMA 3R rated, depending on the environmental conditions. Thirdly, the type of conduit used also affects the material cost. Electrical metallic tubing is a common choice for this type of installation, but other options include rigid metal conduit and intermediate metal conduit. The choice of conduit depends on the application and local electrical codes. Fourthly, labor costs depend on the complexity of the installation and the hourly rate of the electrician. Factors that can increase labor costs include difficult access to the installation location, the need to work in confined spaces, and the presence of existing electrical wiring that needs to be worked around. Fifthly, permits and inspections are required for most electrical installations. The cost of permits varies depending on the location and the scope of the project. Inspections are conducted by local electrical inspectors to ensure that the installation meets safety standards and code requirements. Sixthly, the cost of the motor load depends on the size and type of motor being connected. Larger motors require heavier gauge wiring and larger circuit breakers, which will increase the material cost. Also, consider the cost of any motor starters or variable frequency drives needed for the motor. Seventhly, consider the cost of any additional components such as disconnect switches, transformers, and surge protectors. These components may be required depending on the specific requirements of the installation. Eighthly, local market conditions can significantly impact the overall cost. Material prices and labor rates can vary depending on the region and the availability of contractors. Ninthly, the contractor's profit margin is another factor to consider. Contractors typically include a profit margin in their bids to cover their overhead and ensure a reasonable return on their investment. A typical profit margin for electrical contractors is between 10% and 20%. Tenthly, unexpected issues such as unforeseen site conditions or code compliance issues can arise during the installation, which can increase the cost. It is always a good idea to factor in a contingency amount to cover any unexpected costs. When soliciting bids from contractors, provide them with as much information as possible about the project, including detailed drawings, specifications, and a scope of work. This will help them provide more accurate bids. Before hiring a contractor, check their credentials and references. Verify that they are licensed and insured and have a good reputation in the industry. Ask for references from previous clients and check their online reviews. Also, get multiple bids from different contractors to compare pricing and ensure you are getting a fair price. Review the bids carefully and make sure that they include all of the necessary materials, labor, and permits. Don't just choose the lowest bid. Consider the contractor's experience, reputation, and quality of work. A more experienced contractor may charge more, but they may also be able to complete the project more efficiently and with better results. Be aware of potential risks and liabilities associated with electrical installations. Ensure that the contractor has adequate insurance coverage to protect you from any damages or injuries that may occur during the installation. Consider the long-term costs of the electrical system. Energy-efficient equipment and proper installation can save you money on your electricity bill over the long run. Discuss energy efficiency options with a contractor and consider investing in higher quality equipment that will save you money in the long run. Understand the warranty and maintenance requirements for the electrical equipment. Make sure that you understand the warranty terms and conditions and that you have a plan for maintaining the equipment to ensure its longevity. Furthermore, consider the following factors for a comprehensive understanding. The type of structure where the installation is taking place, whether it is a commercial building, industrial facility, or residential property, can influence the cost due to varying code requirements and installation complexities. Also, assess the accessibility of the location for equipment and personnel. Difficult access can increase labor costs and potentially require specialized equipment, impacting the overall price. Moreover, the condition of the existing electrical infrastructure, including the panel, wiring, and grounding system, might necessitate upgrades or repairs, adding to the project's cost. Consider any specific requirements or regulations imposed by local authorities or utility companies. Compliance with these requirements may involve additional expenses. Consider the potential for future expansion or upgrades. Designing the system with scalability in mind can save costs in the long run. Examine the environmental conditions such as temperature, humidity, and exposure to corrosive elements, as they may require specialized materials or installation techniques. Ensure proper coordination between the electrical contractor and other trades involved in the project, such as mechanical, plumbing, or structural contractors, to avoid delays and conflicts. Evaluate the energy efficiency of the proposed equipment and design. Consider options for reducing energy consumption and lowering long-term operating costs. Assess the need for surge protection and backup power systems, such as generators or uninterruptible power supplies, to protect sensitive equipment and ensure business continuity. Consider the impact of the installation on existing building systems, such as lighting, HVAC, and fire alarm systems, and ensure that they are properly integrated. Plan for proper commissioning and testing of the electrical system to ensure that it operates safely and efficiently. Consider the need for ongoing maintenance and support. Establish a maintenance plan to ensure that the system continues to operate reliably over time. The cost of materials can fluctuate due to market conditions and supply chain disruptions. Obtain updated quotes from suppliers to ensure that you have the most accurate cost estimates. Labor rates can vary depending on the experience and qualifications of the electricians. Higher skilled electricians may charge more, but they may also be able to complete the project more efficiently and with better results. Permit fees can vary depending on the location and the scope of the project. Contact the local building department to obtain accurate permit fee information. Inspection fees are typically based on the size and complexity of the electrical system. Contact the local electrical inspector to obtain accurate inspection fee information. The cost of insurance can vary depending on the contractor's insurance coverage and the risk associated with the project. Obtain proof of insurance from the contractor and verify that they have adequate coverage. The cost of financing can vary depending on the interest rate and the terms of the loan. Shop around for the best financing options and compare interest rates and terms. In addition, consider the following points. The type of wire or cable used, such as THHN or XHHW, can impact the material cost. The size and number of conductors required will also influence the price. The type of connectors and fittings used to terminate the conduit and wiring can affect the material cost. Consider using high-quality connectors and fittings to ensure a reliable and long-lasting connection. The type of grounding system used, such as a driven ground rod or a concrete-encased electrode, can impact the material cost. Ensure that the grounding system meets the requirements of the National Electrical Code Section 250. The type of overcurrent protection devices used, such as fuses or circuit breakers, can affect the material cost. Consider using circuit breakers with adjustable trip settings for greater flexibility. The type of disconnect switch used, such as a fusible disconnect or a non-fusible disconnect, can impact the material cost. Ensure that the disconnect switch is properly rated for the voltage and current of the circuit. The type of transformer used, such as a dry-type transformer or an oil-filled transformer, can affect the material cost. The size and voltage of the transformer will also influence the price. The type of surge protector used, such as a whole-house surge protector or a point-of-use surge protector, can impact the material cost. Consider using surge protectors to protect sensitive electronic equipment from voltage spikes. The type of generator used, such as a standby generator or a prime power generator, can affect the material cost. The size and fuel type of the generator will also influence the price. The type of uninterruptible power supply used, such as an online UPS or an offline UPS, can impact the material cost. The size and runtime of the UPS will also influence the price. The type of lighting fixtures used, such as LED fixtures or fluorescent fixtures, can affect the material cost. Consider using energy-efficient lighting fixtures to save money on your electricity bill. The type of HVAC system used, such as a central air conditioning system or a ductless mini-split system, can impact the material cost. Consider using energy-efficient HVAC systems to save money on your electricity bill. The type of fire alarm system used, such as a conventional fire alarm system or an addressable fire alarm system, can affect the material cost. Ensure that the fire alarm system meets the requirements of the local fire code. The type of communication system used, such as a telephone system or a data network, can impact the material cost. Consider using communication systems that are compatible with your existing infrastructure. Consider the costs of labeling and identification of all electrical components. Proper labeling and identification can help to ensure that the system is operated and maintained safely and efficiently. Consider the cost of training personnel on the operation and maintenance of the electrical system. Proper training can help to prevent accidents and ensure that the system is operated safely and efficiently. Consider the cost of disposal of any waste materials generated during the installation. Dispose of waste materials properly to comply with environmental regulations. Consider the cost of cleanup and restoration of the work area after the installation is complete. Ensure that the work area is left clean and safe. The estimated cost range of $15,000 to $25,000 should be viewed as a preliminary estimate, subject to change based on the specific factors outlined above. Engaging with qualified electrical contractors and obtaining detailed quotes is crucial for accurate cost assessment and successful project execution. The NEC, or National Electrical Code, is a comprehensive set of standards and guidelines for electrical installations. It addresses safety requirements for electrical wiring, equipment, and systems. Adherence to the NEC is essential for ensuring the safety of people and property. Several NEC articles are particularly relevant to the described electrical installation. NEC Article 210 covers branch circuits, including requirements for conductor sizing, overcurrent protection, and receptacle outlets. NEC Article 220 covers branch circuit, feeder, and service calculations, providing methods for determining the ampacity of conductors and the size of overcurrent protection devices. NEC Article 230 covers services, including requirements for service conductors, service equipment, and grounding. NEC Article 250 covers grounding and bonding, providing requirements for grounding electrical systems and equipment to minimize the risk of electric shock. NEC Article 300 covers general wiring methods, including requirements for wiring in raceways, cables, and other wiring methods. NEC Article 310 covers conductors for general wiring, including requirements for conductor ampacity, insulation, and marking. NEC Article 314 covers outlet boxes, conduit bodies, and handhole enclosures, providing requirements for the installation and support of these enclosures. NEC Article 344 covers electrical metallic tubing, providing requirements for the installation and support of EMT. NEC Article 430 covers motors, motor circuits, and controllers, including requirements for motor overcurrent protection, motor disconnecting means, and motor control circuits. NEC Section 110.3 covers examination, identification, installation, and use of equipment, emphasizing the importance of using listed or labeled equipment and following manufacturer's instructions. NEC Table 310.15b16 provides ampacity ratings for insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air. This table is used to determine the appropriate conductor size for a given ampacity rating, considering the conductor's insulation type and temperature rating. NEC Table 310.16 provides allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current-carrying conductors in a raceway or cable or earth. This table is used to determine the appropriate conductor size for a given ampacity rating, considering the conductor's insulation type, temperature rating, and the number of current-carrying conductors in a raceway or cable. NEC Section 250.122 covers equipment grounding conductor sizing, providing requirements for determining the size of the equipment grounding conductor based on the size of the overcurrent protection device. NEC Section 430.52 covers motor overcurrent protection, providing requirements for selecting the appropriate overcurrent protection device for a motor, considering the motor's full load current and starting current. NEC Section 430.110 covers motor disconnecting means, providing requirements for selecting a disconnecting means that is capable of safely disconnecting the motor from the power supply. NEC Section 430.125 covers motor control circuits, providing requirements for the design and installation of motor control circuits, including control circuit conductors, overcurrent protection, and disconnecting means. Understanding and applying these NEC articles and tables is crucial for ensuring a safe and code-compliant electrical installation. Always consult the latest edition of the NEC and local electrical codes for specific requirements and regulations. Additionally, it's crucial to remember that electrical work involves inherent risks, and only qualified and licensed electricians should perform such tasks. Safety precautions must be strictly followed to prevent electrical shock, fires, and other hazards. Always energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. Regular inspections and maintenance are essential for ensuring the ongoing safety and reliability of electrical systems.